All right, we've just covered a bunch of sort algorithms and we've implemented those algorithms in Java. So suppose you have an array that you want to sort in a Java application. Do you implement one of those algorithms to sort the array? Well, you can, especially if you can use one of the linear sort algorithms that makes assumptions about the data. But if you can't do that, if you can't make any assumptions about the data, if counting sort and radix sort aren't suitable, do you go ahead and implement one of the algorithms? Well, you don't have to because, hey, it's Java. We have the JDK at our disposal. And the JDK contains an arrays class, and that class has methods that sort arrays. So let's take a look at the arrays Java doc. I've got it on the screen. So right at the top, it says this class contains various methods for manipulating arrays, such as sorting. So let's scroll down and take a look at the sort methods. As you can see, there are a lot of methods here, and boom, look at all these methods as well. So these are all methods for primitive types, but you'll see that you can also sort objects. Now, if you want to sort objects, of course, you have to tell the runtime how to sort those objects, and so you'd implement the comparable interface. That's what the natural ordering would be. It would be based on the comparable. You'll also notice that there are sort methods that sort the entire array or just a part of the array. So you don't have to implement these sort methods when you want to sort an array in Java. As I said, we've got a whole library at our disposal, and the arrays class has sort methods. So let's go back to the IDE now and call the appropriate sort method on our usual example array. So I've created a project, I've put the code into academy.learnprogramming.sorting arrays, and I've created our usual array. We've gone back to our 7-element array that we were working with before we looked at counting sort and radix sort, and I have the usual code for printing the array. So we want to sort this array, so let's just call arrays.sort, and we'll just pass it our int array. And let's run. And there we go, -22, -15, 1, 7, 20, 35, and 55. So that's wonderful. But now that we know about all these sort algorithms, we might ask, well, what sort algorithm is it using? So let's go to the source code for this. So I'm going to right-click and say go to the declaration. And here we are, and we'll see that it's using something called a dual pivot quicksort. And we can see from the comments that this is a modified form of quicksort that doesn't degrade as much for larger data sets, and it's typically faster than the quicksort that uses one pivot. So this algorithm offers O(n) to the log n performance on many data sets that cause other quicksorts to degrade to quadratic performance. Remember that I mentioned that in the worst case, quicksort is a quadratic algorithm, but in the average case, it's O(n) log n. It also says that a dual pivot is typically faster than traditional one pivot quicksort algorithm. So if you are interested in looking at how this dual pivot quicksort algorithm works, you could probably find an article out there on the web somewhere that will explain what it's doing, but we can guess that it's using 2 pivots rather than 1. The arrays class also has a bunch of parallel sort methods. So let's go back to our main class here and let's call parallel sort instead of just plain old sort. Parallel sort. It's giving me this error because even though I'm using Java 9, for some reason the language level it sets is sometimes lower than that. So this has only been available since Java 8. And so if you see that, a light bulb should come up. Where'd that light bulb go? And then you can just say, set my language level to Java 8, please. And there we go. So that's how you fix that error. So let's run. And once again, we have our sorted values, -22 up to 55. But what's this doing? Well, let's go to the source code. So we'll right click, go to the declaration. I'll close this down for a minute. And if we scroll up, we'll see it's a hybrid algorithm of sorts. It's a parallel sort merge that breaks the array into subarrays that are assorted and then merged. But when the subarray length reaches a minimum granularity, the subarray is sorted using the appropriate arrays.sort method, which we know is quicksort. So it's doing a merge sort, but when it's dealing with smaller partitions, it's sorting them using quicksort rather than just traversing the arrays and copying the smaller element into a temporary array. It's also using threads, and that's why it's called parallel sort. So this sort might be faster for larger data sets. So if you have a larger data set, using parallel sort might result in a faster sort. You'd have to run some benchmarks to decide whether to just call sort or parallel sort. And that's all I wanted to do in this video. The point is that it's good to understand the different types of sort algorithms, but you don't necessarily have to implement them yourself. And you'll see the same thing when we look at some of the upcoming data structures. Java has a lot of support for commonly used data structures. So you rarely have to implement the data structure yourself. There is often a class in the JDK that has already done it for you, or if there isn't, you can usually find a third-party library that has an implementation that you can use. So the bottom line here is that you don't have to write the sort code when you want to sort an array. You have methods available to you in the JDK. And so unless you want to use counting or radix sort, or unless for some reason you don't want to use a dual pivot quicksort, or you don't want to use a merge sort quicksort hybrid, you'll typically just go ahead and use one of the sort methods in the JDK. And if you want to sort an array of objects, remember that you'll have to implement the comparable interface so that the method knows how it's supposed to order your objects when it's doing the sort. All right, I'll see you in the next video.